Next problem number 130. It is aeroplane problem. 2-3 types of problems are there of the same aeroplane with a different data. Please check up that, they are important ones. Takeoff speed of the aeroplane is given as 198 km per hour. Compared to helicopter, no, aeroplane has to run on the runway for some distance and takes off. Due to that reason, they provide the small wheels compared to their body size, so that they do not complete the runway, or they take more time to complete the runway. Here velocity, final velocity starting from rest, the final velocity just to take off is nothing but equal to 198 km per hour. Converted to meter per second, that becomes equal to 30 meter per second, and the runway length is given as 100 meters, mu equal to 0.2, and mass is of the aeroplane is 10 to the power of 4 kg, or 10 into 10 to the power of 3, 10 to the power of 3 kg is 1 ton, means 10 tons we can take. What is the force required to pull it forward direction? The property is pulling forward directions. Due to the Bernoulli's principle, what you get, this area of cross section of the wing is different on the top and bottom. More speed on the top for the air molecules takes place compared to the bottom. Due to that reason, low pressure is created on the top compared to the bottom. The high pressure at the bottom lift the wings up. Along with the wings, aeroplane is lifted upwards. To provide the difference in the velocity, it has to run some distances. And here propeller is providing the force equal to first force F forward direction, called as the thrust we can take. So work done by this force is nothing but equal to change in kinetic energy. Change in kinetic energy, initial kinetic energy is 0. So you are taking only final kinetic energy equal to work done. What is the work done equal to? Total force in displacement is the work done. Straight line we are taking. Total force is nothing but equal to mu mg. Here actually air resistance also acts, because the drag in this problem it is not mentioned. Only friction with the wheels and ground only mentioned. On the horizontal surface, friction force is nothing but equal to mu mg, and external force is equal to F. Total force, resultant force is nothing but equal to external force minus frictional force into S. Force into displacement, resultant force displacement is the work done is equal to change in kinetic energy half mv square minus half m u square. U is 0 here. So external force, if we equated this negative term take it to the right side becomes a plus, so yes, go to the denominator here and substitute the values you will give. F external equal to 6.46 10 to the power of 4 newtons. Next question number 176. In this block is kept onto the wall, but force is not applied normally like before we said. It is applied at some inclination. Sometimes same problem may be given with the force upwards, but in this problem force is given downwards. I can apply the force normally, then normal reaction itself is F it becomes whatever force applying. Weight is always acting downwards, frictional force is acting opposite to the sliding object. It is trying to slide downwards, means the frictional force opposite that in the direction, upward directions. Frictional force is not necessarily always opposite to the direction of motion, please careful with that term. If the sliding objects, for the sliding objects only, frictional force is opposite to the direction of motion. If you take the level surface like this, object is trying to slide right hand direction, it is trying to go this side, then frictional force is opposite direction. So external force is in the direction of motion, means frictional force opposite to this motion, opposing it. So work done the friction is negative in this case, but not always the same. If the person is walking towards north, this is north side direction. If the person is walking towards north, he has to push the ground backward directions. He has to push the ground backward directions, and ground, the friction force opposing this feet only, not person. Opposing the feet, the friction is acting in the forward directions. So friction is acting forward direction, motion is also in the same direction. So for the person walking towards north, the friction is also same direction, but the block which is pulled towards north, the friction is towards the south, opposite direction. Careful with that. Even the vehicle wheels, if you take the cycle wheel, the back wheel is pedaled, front wheel is not pedaled generally what we take all the cycles. So with the back wheel is connected to the pedal with the chain and you are rotating it. So you are rotating only the back wheel. When the back wheel is rotated, the front wheel and the whole cycle is pushed forward direction here. When the wheel is rotated backward direction, molecule trying to go backwards, the friction force opposes this motion, the friction force is in the forward directions. So cycle is going forward, north towards north, means friction force also towards north. For the wheel which is connected to the powering, means the which one we are powering it. Same thing for the car also, the wheels connected to the engine, friction force in the direction of motion only. But other wheels not connected to the engine are here not pedaled, not powered. For that wheel actually you are pushing it forward, all the molecules pushing forward, it is trying to slide forward. So friction force opposite that will be backward directions. The friction force provides the torque here, force into this friction force Fs actually into the radius is nothing but equal to torque. The torque rotates this wheel, front wheel, because of this torque, and that corresponding friction is called as a rolling friction. But here static friction is providing the rolling friction. Here friction is required for the wheel to roll for front one direction. If the friction is not there, the whole cycle simply skids forward directions. Compulsory friction is required for these wheels to move forward, means rotational motion converted into translative motions. So here Friction is need not be always in the same direction of opposite direction of motion, that you have to check up. In this problem, force is applied inclination downward directions. Force applied normally means F normal reaction equal to F. Force can be applied upwards also. Force can be applied downwards also. In that case, resolve the force into components. In this case, the force is applied towards the downwards, towards the wall at angle equal to theta. You have to be careful with this also. Theta is with the horizontal or with vertical also. And theta's direction, whatever the known angle set, we take the cos component of this force F. So, P is a force given symbol in this direction is acting, resulted two components, perpendicular components, horizontal and vertical. What horizontal is P cos theta, vertical is nothing but equal to P sin theta. So, weight is also acting for this block, weight is nothing but equal to mg. Sometimes they give the symbol W in place of mg, that also you need to be careful. Normal reaction, this P cos theta is pushing this block towards the wall, and normal reaction this is action. So, normal reaction is opposite that, is n, we take n is equals to P cos theta, and downward force is nothing but equal to P sin theta plus this component of the P sin theta plus the weight mg. The friction force, suppose this it is at rest, means Fs is supposed to be equal to the downward force, but Fs is also equal to mu into normal reaction. Normal reaction is nothing but equal to P cos theta. So, n equal to P cos theta, Fs equal to mu into normal reaction, this is mu into n, means mu P cos theta, and a block is at rest, therefore, frictional force, upward frictional force equal to downward total force acting downward, that is mg weight plus P sin theta. So, mg plus P sin theta. The Fs is equal to mg plus P sin theta, Fs is substitute from the previous solution, mu P cos theta equal to P sin theta plus mg. So, mu, take this to the left side, mu P cos theta minus P sin theta equal to mg. We want the expression for P in this question. So, P is the force is equals to mg by mu cos theta minus sin theta is the expression. Next, block at rest is given, question number 181. Block is at rest, you have to find out the coefficient of friction. Here also force is applied, it is on the horizontal surface, and force is applied at some inclination with vertical given, careful with that. Angle is with vertical, previously we have taken the angles with respect to horizontal, here with respect to vertical, and two forces are acting. One is Q acting at some angle downwards at the angle theta with vertical, and P is the horizontal force acting horizontally, P is a force acting horizontally. So, these two forces interacting at the center of mass at any point on the body, we can check up. Then in that case, depending on the theta, this Q is acting downwards. So, this is theta with vertical, this is also with vertical, means the theta, opposite angle is theta. So, Q is downward directions resolved into components. Q known angle side, what you take is Q cos theta, and weight is also acting downwards. So, Q cos theta plus mg is the total force acting downwards, and the horizontal direction is nothing but equal to this Q. What you have is equal to Q sin theta, Q cos theta, Q sin theta. P is also acting horizontally. So, total horizontal force is nothing but equal to P plus Q sin theta. Next, normal reaction, upward force equal to downward force, because it is not moving vertically and also not moving horizontally, means horizontal force along the x axis also force are equal, and vertical direction along the y axis also force are equal. So, n is supposed to be equal to Q cos theta plus mg you have to take, and frictional force, left side force is nothing but equal to right side force, that means Fs equal to P plus Q sin theta, but Fs is also equal to this frictional force equal to mu into normal reaction. Normal reaction is Q cos theta plus mg. Equating these terms, what you get is Fs equal to Fs, left side force equal to P plus Q sin theta, Fs is mu n equal to P plus Q sin theta, n is nothing but equal to mg plus Q cos theta equal to P plus Q sin theta, expressing for mu becomes equal to P plus Q sin theta by mg plus Q cos theta. Okay, next points only. Angle of repose. Angle of repose is the minimum angle of the inclination where the object starts sliding. If you take any horizontal surface, there is no external force, which there is no frictional force, and the object will not try to move only. But if you are going on inclining this surface at a particular angle, the angle of going on increasing, object is not moving. So, what you are finding is nothing but equal to static friction, object is at rest. So, at a particular angle the object starts sliding, that is called that ready to slide. The object is ready to slide, that angle is called as the angle of repose, reposition. Means if the angle is less than that, again it come to rest, you can reposition to the rest position. That angle symbol is taken as alpha or phi. This is the minimum angle for the object to start sliding actually. So, friction force is opposing this mg sin theta. When object is at rest, friction equal to mg sin theta, both are equivalent only. Friction equal to mu mg cos theta on inclined surface we are taking. So, if the theta angle of inclination is less than this angle of repose, object will be at rest. So, friction is nothing but equal to static friction we have to say. And if the theta is equal to alpha, object is ready to slide, we call it the limiting friction, the friction force equal to mg sin theta in all these cases. Next is the limiting friction, in this case this is a static friction. Limiting friction is also static, but maximum static we call it as. If theta is more than alpha exceeding angle, then object accelerating downwards, in that case resultant force mg sin theta is more than fs, mg sin theta minus fs equal to ma we have to take, and we will get the acceleration a equal to g sin theta minus mu cos theta is equal downwards. But if you take this limiting friction condition, this limiting friction condition, when you take theta equal to alpha, then tan alpha becomes equal to mu s, because mg sin theta mg sin theta equal to fs, fs equal to mu mg cos theta, the ratio becomes equal to sin theta by cos theta is equal to tan theta, means tan alpha is equals to mu s, when the condition theta equal to alpha only, tan alpha equal to mu s. This point is also important for us. This angle of repose, if it is given, means you can find out the mu s from that relationship. Next term, angle of friction is not there in your syllabus actually, but it can be asked for the JEE and other exams, not for KSET mostly, but both are same only. There is only name, definition is different. Angle of friction is nothing but the angle between the normal reaction and the resultant of normal reaction and frictional force. If the external force is acting towards right side in the block, frictional force oppose that and the sliding body that is acting towards left. The angle, the resultant between the n and fs is nothing but equal to resultant force, we take like this. The angle between the resultant and this normal reaction is taken as equals to this angle of friction, it is called as a phi. And at this point the object is ready to slide, again you will get the expression equal to tan phi or tan alpha, tan theta, what you take symbol is equals to mu s only, you will get the relationship. Fs equal to mu mg cos theta equal to ma, that condition. If you take mu mg sin theta equal to cos theta, you will get the expression equal to tan phi is equals to mu s. You can take this opposite side, tan phi is equals to opposite side by adjacent sides, so it is mg, n equal to mg. Next, pushing and pulling conditions, which is easy, and in which case the friction is more, and what are the expression for the minimum force just to start sliding, or maximum force till the object is at rest. If they ask it as a minimum force or maximum force condition only, but object is ready to slide or still at rest, meaning is same only. If you take the pulling of the object, when you take any object and pulling it, when you are pulling it at some angle, upward directions, the force is resolved to components. Angle is the theta is the angle between the force and horizontal. Be careful with that, because with respect to vertical given means the formulas we are using with the horizontal, we check up that. Total is 90. With vertical given means don't use that angle, use with respect to horizontal for these formulae. So force F is resolved to components. Horizontal component is F cos theta, vertical component is F sin theta. So weight is acting downward directions. Okay, normal reaction is upward direction, this is action, normal reaction. So n plus F sin theta is supposed to be equal to mg. Frictional force is opposing this object, external force is right side means frictional force is left side. So you will get is the relation n plus F sin theta equal to mg, object is at rest, therefore n equal to mg minus F sin theta you will get, that is the normal reaction. And frictional force is nothing but equal to mu into normal reaction, because you are getting this normal reaction mg minus F sin theta, minus is coming, due to the minus is coming, this frictional force, friction is less, friction is low, easy to pull, and because friction is less, and apparent weight. The normal reaction itself is called as apparent weight. Apparent weight is equals to mg minus F sin theta. Weight is decreasing. So when you are pulling the object at some, applying the force at some horizontal inclination with at angle theta with respect to horizontal, then apparent weight decreases. That means object appears lighter, and frictional force also decreases. So it is easy to move. So pulling is easier compared to the other method called as a pushing of the objects. And at rest, still at rest means F is equal to Fs, frictional force equal to forward force F cos theta, external force, here external force is F cos theta, and minimum force required from this expression substitution will get mu mg by cos theta plus mu k cos sin theta. Here this mj they may give symbol as a w sometimes, this mu w they may give, you check up that. In this case we can take this divided with this, here in this case cos sin theta you can take out common and get the expression for this in terms of the angle of friction or angle of repose, both are same only. They may mention in terms of the phi, but that is not for the KSET, not for the NEET, it is asked only for the JEE and other higher exams. That formula you just check up in that. Next, pushing. Pushing, it is difficult compared to the pulling of the object. Pushing means you are applying the force downwards, you are pushing like this. When you are pushing at an inclination downward direction, the force is downwards. So with respect to horizontal, the angle is theta, here also theta. F is related to components, horizontal component is nothing but equal to F cos theta, vertical is nothing but equal to F sin theta, but already weight is acting downwards. So F mg plus F sin theta is the total force acting downward directions. So n supposed to be equal to upward force equal to downward force at equilibrium. So, normal reaction N becomes equal to mg plus F sin theta. Normal reaction symbol, sometimes they will give the capital R also, that symbols you have to check up. Next, frictional force Fs is nothing but equal to mu into normal reaction, but a normal reaction is mg plus F sin theta. This itself is apparent weight. That means apparent weight, previously we got minus, but you got a plus, means now apparent weight increases, weight increases, and weight increases means this N increases, means frictional force also increases. So, Fs is high in the case of the pushing compared to that of the pulling. And minimum force, what you get is one formula, if you remember, other easily can write it, plus comes in the denominator for the pulling, it is easy, plus denominator means what, more value at the denominator means less value for the force. But for the pushing, it become this plus be replaced with the minus, is minus is there means force is maximum. So, it is a more force you will get, more force required, here less force is required for the pulling cases. This is the end of the topic, and in this one insect crawling in the ball is also there, that may not be asked for the case set, but it can be asked for, previously asked for case set, but it may not be this time, but just have a check into that formulas, I will give the hint, and for the NEET and JEE that problem is important. And also death, well of death is also there in this, one drum will be there, it is rotated, this comes in the rotator motion topic also, and persons will be made to stand inside, there is a lid at the bottom, the drum is made to rotate after some time, after rotating with some angular speed, the radius of this drum is R, hollow drum, hollow cylinder we can say, the bottom lid is opened. Now, it is open on the top and bottom, but the person will be sticking to the walls, because the centrifugal force, which is a pseudo force mainly, the force will be pushing them to the walls, and weight is acting downwards, frictional force is acting up forward direction. What is the centripetal force is nothing but equal to mv square by r equal to m omega square r. This upward force, frictional force is nothing but equal to mu into F, normal reaction itself is centripetal force, mu into F, then downward force is nothing but equal to mg. You will get the expression required for this omega, what is the minimum omega or minimum v required to rotate it, that expression you check up. It is independent of the mass of the person. So, all the people standing inside will be sticking to the walls because of this pseudo centrifugal force. And also please check up the objects on the truck, sliding on the truck, that problem is also important. If the truck is moving, there is some object on that truck. Truck as long as moves with a constant velocity, there is no problem, but it accelerates, problem comes, sudden brakes applied also problems comes. Sometimes the trucks carrying with heavy loads of the iron and stones, when suddenly applied brakes, the stone will go forward direction due to inertia of direct motion and crush the cabin and the drivers. It happened many times, and due to that reason the trucks should be travel with the uniform speed, constant velocity, no problem. But if you accelerate forward direction means the pseudo force acting in the backward direction now, the pseudo force is nothing but equal to this mass of the block m into A is the pseudo force. It is trying to slide backward direction due to the pseudo force, that means friction is acting forward directions. The minimum speed or maximum acceleration required for the block at rest is nothing but equal to A equal to mu g. If the acceleration is more than this, then what happens here is this A minimum for the rest purposes. You can take it as A maximum also can be taken, max acceleration, so that object is at rest is nothing but equal to A equal to mu g. If it is more than that, what happens is acceleration equal to this net resultant acceleration is nothing but equal to A minus mu g. If the acceleration of the truck is more than that mu g, then you have to take the acceleration of the truck minus mu g equal to A prime, and distance after what time it falls out of this truck, the distance s equal to ut plus half t square, that A whatever you are using you have to replace with the A prime. Same truck, if the block is kept in the front, truck is going forward right side and one block, one object block is sticking to the front, no gum, just touching it, it is accelerating forward directions, the weight is acting downwards, not falling down, then the frictional force acting upwards opposes this, Fs equal to mg. What is Fs equal to is this pseudo force acting backward direction is nothing but equal to F equal to ma you have to use, acceleration of the truck into m, Fs equal to mg equal to mu into normal reaction, which itself is normal reaction. You check up the formulas of these points. And what else is left out is coins removing, that also please check up. Nth coin pulling out while playing the carom boards, nth coin if you want to pull out, what is the force required, that problem is also important, including for case set. I will provide the hints, please check up those problems.